All right. So, hopefully you had a good lab yesterday. I'll talk more about that. It also occurs to me I did not properly introduce myself and all the hats I wear on Tuesday. So, for those of you who haven't figured it out yet, I am Professor Rosen, and not just some random person impersonating him. I am, besides your professor, for 2168, I teach 1051. I also teach the graduate version of this class, which is 5016. And by graduate version, I mean we have a master's in IST, which is not made for IST majors, but designed to take people who have a bachelor's in, like, say, psychology or something like that, and give them a curriculum that turns them into a programmer or adds programming to them. So 5016 is essentially an accelerated 1051 plus 1068 plus 2168. But the vast majority of the content is from 2168. And so when we created that course, I had started flipping the classroom for 2168, and I realized, wait, since there's such a good overlap, and I have to make higher quality videos for that anyway, I'm going to backport a bunch of the videos. So you'll start seeing a lot of those backported videos starting with the array list videos, which is week 2. If you see stuff that's a bit older looking, where I'm working in Linux on a laptop in my office, that's because it's one from the first batch of videos and wasn't covered in 5016. So, that's why you might see different quality videos of a different Andrew Rosen at different stages of hair growth and age and weight. Let's see. Aside from my teaching responsibilities at this university, so I'm what we call a professor of instruction, an associate professor of instruction. That means that I'm not a tenure track professor. My primary responsibility is teaching. So I don't do much research. Occasionally, I do end up doing I do sponsor students for independent study or stuff like that. But it's mainly for projects I find particularly interesting. When I do end up doing research, it is generally these days in computer science education. We might have a couple of experiments come in this semester around AI usage, which will involve. And those would involve basically doing whatever we would normally be doing with an in-class exercise, but using the tool that the graduate student has come up with. So that's something that might happen. I'm also the advisor for a number of the programs here at Temple. So that means that I'm in charge of approving basically overrides or alternatives for courses or possible elective selections for basically all 3 of the data science concentrations. So we have 3 separate data science concentrations. One that's just basically core data science, which is computer science and math. Then we have computational modeling, which is data science computational modeling, which is, you can think of that as computer science and physics. And then we have the bioinformatics one, which is, as you can imagine, biology. I also am the advisor for computer science physics, computer science math dual degrees. So those are basically those rip out the elective choices from both those degrees in order to get a core in either in computer science and either math and physics. So you don't get a lot in the way of elective choices. What you do end up with is basically the core of 2 separate degrees without having to do two degree programs. And then finally, we're coming up with a new AI major, and I might end up as the advisor for that. On the master's side of things, I'm also the advisor for a few master's programs, including the Computational Data Science Masters, and most relevantly for all the people in this class, the 4+1 program, which is the accelerated program. Minimum requirements are a 3.25 GPA, but if you fulfill that requirement, then you can think about enrolling in basically a 5th year, which doing that would essentially allow you to get your master's degree and bachelor's degree together in 5 years rather than 6. The requirement is that essentially you've got, if you're in computer science or or data science, you know that you have this selection of electives to take, right? And what we do is we simply add a bunch of graduate courses to that electives list that then double count for your undergrad and your graduate degree. So those are different options that you have. Oh, I'm not done yet. So I also am essentially the unofficial official liaison for our department for Temple Japan. I helped get some stuff running there, so now there are classes that you can take at Temple Japan, which is eventually, and that got the ball rolling to them being able to offer a full degree program at Temple Japan for computer science. So you can take basically all the classes you need to at TUJ. So if you're interested in studying in Japan, let me know. I've taught there twice now. I don't know when I'll be going back. Probably not this year, but probably in 2027. I've also taught 3223 once, which is the course after this, and please let me know if you are interested in taking that as a 12-week course over the summer, because I want to see how much support we could have for that, because if I can get enough students kind of lined up to enroll in that, that makes it much more likely to run as an online 12-week course over the summer. So because that's a course that's pretty in high demand in the fall. All right, and then last but not least, I am the faculty advisor for TU Dev, and if David was here, he'd tell you more about that. He's the president of TU Dev, but that's one of the programming hobby clubs that we have here, as well as the faculty advisor for the TU Gamers Guild, which is not the e-gaming club, but rather just the general games club. That also happens to do a lot of e-gaming, but basically if you're interested in Dungeons & Dragons, board games, Magic the Gathering, collectible card games, and that kind of stuff like that, that is the club to join. And so if you're interested in either of those clubs, please reach out to me. All right, so that's enough about me. And if you haven't figured it out, I love video games. So that's enough about me, but I just want to kind of put that information out there so that you could feel comfortable asking me questions about those things, right? You don't have to. Office hours are not necessarily constrained to the contents of this class. In fact, if I didn't mention something, but you do have a question for me, you're more than welcome to bring it up in office hours. The worst I'll be able to tell you is that's not something that I'd be able to answer. But I could probably direct you to somebody who can. All right. So yesterday you probably saw, yesterday hopefully you had a pretty good lab with being able to work on this program, right? Yes? Were people in lab yesterday? In class? Oh, right. I had to enter a special override for you, didn't I? Right. So, okay. People who were in lab went well. Okay. Hopefully you were able to make some good progress on that. If not, I will be able to, answer questions regardless. The way this course generally ends up is that over the next couple of weeks, we will end up in a bit of a spread over the material, which is that we will have some students who are like a week or so ahead, students who are on time, and students who are a week or so behind. And as long as you're not falling more than a week or so behind, that isn't too bad. We obviously don't want you to fall behind. But if you're more than a week behind, then you're probably in trouble and you should speak to me so I can get you as caught up as possible. But simply put, this course does allow you to basically go to go somewhat at your own pace. And so if you're a bit behind and you need to talk about last week's stuff with me any of the weeks, then yeah, I'm not going to be annoyed or anything like that. Similarly, if you want to work ahead, I'm not going to be annoyed about that. Just be aware that if you're ahead and somebody has more pressing questions about this week's work, I might prioritize them over you because they have a bit of a closer due date. All right. So last lecture, I left you off with this, which is that the idea here is that we could respond to the fox by looking around in every direction and then responding to it. This is the base of basically our first strategy for survival, which is the strategy of basically you abuse the line of sight. Doing this allows you to build up to quite the high survival rate. The key here is, though, why does this rabbit die to the fox 75% of the time about? And the answer is because right now it's basically saying if I see the fox dodge to the left, but if I'm in a position where I can't dodge to the left, I'm in trouble. Also, if I end up dodging to the left and he's right next to me, then he's still going to see me because I didn't move into out of his line of sight. The key here is to build up alternatives by using a function built into animal, the can move function, which tells you if an animal can move in that direction. An animal cannot move off the edge of the array or onto a bush, but it can move onto another animal. So very simple. If the direction you're asking about is staying put, then it's going to go yes. If the distance to the direction is greater than 1, then yes. Otherwise, it's asking otherwise it's going to ask if it's a bush or an edge, in which case it can't. You can't move in that direction. So basically, that's how it works out. It just kind of it will return true or false to let you know. And again, being able to return true or false like that, being able to surround basically this statement in a can move can tell you whether you want to even try moving in that direction. Because remember, doing a return like this ends a function, right? Returning is the last step you can get. So, are there any questions overall before I start going around the class and seeing where everybody is? Most classes, but like this, are fairly. Most of these presentations are, again, fairly short, like this. And so, a lot of the time in these classes will be dedicated to being able to do the work. If you're already done with this, then I would highly recommend, what we're going to do is go to Canvas. No, not Canva. That's no. Canvas. Jeez. I swear I know how to type. It's this protective cover I put on. All right. Somebody's having fun. All right. So, modules. If you're done with today's with the Fox and Rabbit, right? You can work on the array list. So we have the videos there. You probably touched on array lists in 1068, correct? Like touched on them, but not necessarily gone in depth. So the idea here with data structures is that we are learning how to organize our data and like individual items of data and pack them together in a way like an array, and putting them in different formats that are useful for us. A list is kind of an extension, a more abstract idea of what an array is doing, but with basically the idea here is that we don't have these arbitrary limits that an array has. An array list just simply implements the idea of a list using an array. And a list, we know what those kind of are, but you write them all the time. I go into quite a bit of detail about that, and this is a very good breakdown of kind of how I'll be teaching these things to you using my videos. So again, this is a playlist, and we'll see basically there's an overview, then half the videos are on let me explain the broad concepts, the abstract things of this is what these are the things we can do with it, this is how we use it. And then the second half of the videos are how do we build this thing from scratch. And when I say from scratch, I'm not necessarily going to be building it as extensively as Java has. In fact, I definitely won't be. What I'll be doing is building a pedagogical model of it. basically a version of it that's useful for teaching. It's close enough to the real thing that you can understand how the real things work, how the real thing works, without having all the exceptions and the weird stuff that the real version would have to deal with. So that's the way that the vast majority of these things work, which is I explain how these things work, and then I build them from scratch. So you're going to be learning how to build these array lists from scratch. Unfortunately, the homework that I give you for that one, and next week's homework, I'll go over this in more detail, is unfortunately is one of the very few busy work assignments that I have, which are very kind of boring stuff where I say, hey, you've got these common functions like checking if items are unique that you probably have done for doing an array with an array, and now we just want to do it with an array list. Assignment 3 is math, and assignment 4 is, again, when we get to our more interesting assignments. In fact, you have 2 interesting assignments, 2 of them, Josephus problem and solitaire encryption. And you're probably thinking, geez, we have to do 2 assignments? No, actually, you get to choose between which of these 2 to do. One is easier, one is harder, and you get 20 extra credit points for choosing to do the harder one. And if you need to bail and do the easier one, they are both working off the same base code. So that's basic. So anyway, that is basically the sequence of the class up to the first exam. First exam, you'll have extra time to work on the Module 4 assignment, and then the first exam will be up through Module 4. That first exam will be on week 6, which means that we can kind of figure that out right now, since we know when our lab is. So this is week 1, 2, 3, 4, 5, 6. So our first exam will be Wednesday, the 18th of February. So, and I will give out plenty of reminders then. I'll even send out a practice exam, and I'll send out a practice exam the week before, and the Tuesday before the exam, we will have a review session. So of that exam, of the practice exam, where I'll go over those answers for the practice exam. So yes.
Are we allowed to have a teacher?
Yes. 1 sheet, paper, front, back, handwritten and or typed. It can be any size you want, so long as it doesn't interfere with the person next to you. Right. So if you want a note card, you can bring a note card. If you want a sheet of paper, you can bring a sheet of paper. You want a sheet of A3 paper, you can bring that. You want to bring in microfilm and a magnifier, as long as you're not interfering with the person next to you, right? Making it inconvenient, as long as you're not making it so that the person next to you is having a hard time, I'm fine with it. Okay. The reason for this is that preparation, I find, is as essential as the actual resource, right? I find actually that making it is, in fact, more useful than having it. So I'm all for having a cheat sheet there. Plus, it does simulate the fact that basically that you would be looking at, even without AI, you'd have access to the internet normally when coding and being able to look up stuff. But the question is, do you know what's useful to look up? All right, I've wasted enough time, so I'm going to go around the class now. And if you have more individual questions, you can feel free to